Why is it so hard to go to Titan? Titan is the largest moon of Saturn. This natural satellite is of great interest to scientists since it contains chemical compounds that living beings could produce, that is, by extraterrestrials in the form of microbes. But despite our great scientific interest in this planet, only 4 space exploration probes have managed to reach this distant world, and only one has managed to land on its surface. Why haven't we sent out more missions to explore Titan? Is it tough to go to Titan? Come with us to find out. Titan, the giant of Saturn. The largest satellite of Saturn was discovered on March 25, 1655, by astronomer Christiaan Huygens. At that time, Huygens had no way of determining the size of this natural satellite, but due to its brightness, he estimated that it could be as large as the Moon. Years later, with more advanced telescopes, the diameter of Titan could be precisely measured, revealing that this satellite was bigger than the Moon and even bigger than Mercury. However, until 1979, the only thing that was known about this gigantic satellite was that it was more significant than Mercury and had an intense brightness, but it was not known why. Pioneer 11 exploration probe flew over Titan and sent the first images of this natural satellite. Later, the Voyager 1 and Voyager 2 probes would fly by Saturn in 1980 and 1981, respectively. When the Pioneer 11, Voyager 1 and Voyager 2 spacecraft flew near Titan in the 1980s, they barely captured a few images of this distant world. The main objective of these exploration probes was to capture data from the gas giant planets. Still, NASA engineers concluded that it would be better to take advantage of the fact that the spacecraft was already close to those moons to bring them closer and take some images of those distant worlds in more detail. That act of curiosity to see what was in that distant world would end up being the beginning of something much bigger. The first spacecraft to fly over Titan was Pioneer 11, taking the first photographs of the satellite, which allowed us to observe a dense, gaseous atmosphere. Thanks to this, the Voyager 1 mission controllers decided that the probe should make a closer approach to this moon, so it was diverted from its initial trajectory to make a closer flyby of Titan at less than 6,500 kilometers. Unfortunately, Voyager 1 had no instrument to penetrate Titan's fog, so data could only be obtained from its upper atmosphere. The information captured by these 3 space exploration probes was initially unimportant. However, years later, thanks to digital processing technology, the images these missions obtained from Titan would be analyzed in detail, discovering impressive things. One of those images was captured by Voyager 1, which, after being analyzed with the orange filter, revealed a substantial dark region on Titan known as Xanadu. The spectral analyses also showed samples of complex chemical compounds such as methane, which indicated that the natural satellite had a dense atmosphere and some chemical elements in a liquid state, possibly water. All this information would be the watershed for the most critical mission ever sent to Saturn. Of course, we are talking about the Cassini-Huygens mission, the mission that revealed the secrets of Titan. The Cassini-Huygens mission was a joint space project of NASA, the European Space Agency (ESA), and the Italian Space Agency (ASI), that aimed to explore the Saturnian system, particularly the planet Saturn and its fascinating moons. This mission represented a milestone in space exploration, providing invaluable information about the composition, atmosphere, and hidden secrets of this distant corner of the solar system. The Cassini probe was launched on October 15, 1997 from Cape Canaveral, Florida. After an interplanetary journey that included flybys of Venus, Earth, and Jupiter to gain gravitational momentum, Cassini finally reached Saturn on July 1, 2004. This journey of nearly 7 years and more than 3.5 billion kilometers was an odyssey of unprecedented space exploration. The Cassini spacecraft was equipped with various advanced scientific instruments, allowing Saturn and its many moons to be studied in detail. However, the crown jewel of the Cassini-Huygens mission was the Huygens probe, designed to descend to the surface of Titan, the largest of Saturn's moons, and study its atmosphere and terrain. The Huygens probe detached from Cassini on December 25, 2004, and descended into Titan's atmosphere on January 14, 2005. Huygens made crucial measurements during its descent and sent data to the Cassini spacecraft, relaying it to Earth. This historic landing on Titan marked the first and only time to date that a probe successfully landed on the surface of an outer solar system moon. One of the Cassini-Huygens mission highlights was the extensive exploration of Titan, Saturn's largest moon and the only celestial body other than Earth in the solar system with a dense, stable atmosphere. The discoveries made on Titan provided unique insight into atmospheric and geological processes unlike anywhere else. Using its specialized instruments, Cassini analyzed Titan's atmosphere, composed mainly of nitrogen, methane, and traces of hydrocarbons. The probe also revealed the presence of extensive organic dunes on Titan's surface, suggesting active geological processes and a complex interaction between the atmosphere and the surface. However, one of the most surprising and significant discoveries of the Cassini-Huygens mission on Titan was the presence of liquid bodies on its surface. Lakes and seas composed mainly of hydrocarbons, such as ethane and methane, were identified. These liquid bodies represented the first direct evidence of stable liquids on a world other than Earth. Additionally, Cassini radars mapped extensive regions on Titan, revealing intriguing geological features such as vast dune fields, mountains, and craters. These discoveries suggested an active and dynamic geological history on Titan, with processes continuously shaping its surface. Another revolutionary discovery confirmed the presence of a meteorological cycle on Titan, with rain and evaporation affecting its atmosphere and surface. Although different in composition from terrestrial rainfall, this phenomena highlighted the complexity of atmospheric processes on this unique moon. On its descent, the Huygens probe also provided crucial data on the composition and structure of Titan's atmosphere. Subsequently, detailed studies of density, temperature, and atmospheric composition revealed essential information about the conditions prevailing on this mysterious moon. Why should we return to Titan? Titan is a very hostile world for life as we know it, especially for humans. Temperatures on Titan are frigid, having an average temperature of minus 290 degrees Fahrenheit. Additionally, the gravity on Titan is much lower than that of Earth. These extreme conditions pose a significant challenge to the existence of life forms based on carbon and water chemistry, similar to those we know on Earth. Additionally, liquid methane and ethane present as lakes and seas on Titan's surface rather than water, suggests that any life form in this environment would have to adapt to widely different chemical compounds from those we know on Earth. Despite these challenging conditions for life as we know it, some scientists have theorized the possibility of life forms based on different chemistry existing on Titan. It has been proposed that microorganisms that used hydrocarbons instead of water as a solvent could exist, since Titan has an abundance of complex organic compounds in its atmosphere and surface. However, these are theoretical speculations, and there is no concrete evidence for the existence of life on Titan. Titan's dense atmosphere and unique chemical composition create conditions unlike Earth's. Life as we know it depends on a complex network of biochemical interactions, and Titan could hamper these interactions by the lack of liquid water and low temperatures. In other words, although Titan is a hostile world for terrestrial life, it has the conditions to host another type of life different from what we know on Earth, in addition to having many resources that a future human colony could take advantage of. In this sense, is sending a human crewed mission to Titan in the short term feasible? Dragon Mission Fly. Although at present there is no proposal for a human crewed mission whose main objective is to study the Titan satellite, there is an uncrewed mission that has that objective. This is the Dragon Space Mission Fly. This proposed NASA mission is designed to explore Saturn's enigmatic moon Titan fully. As part of NASA's New Frontiers program, Dragonfly's main objective is to study Titan's prebiotic chemistry and potential habitability, considered a unique window into Earth's past and the processes that could have led to the origin of life. What is the most distinctive about Dragonfly is its innovative approach. Instead of moving across Titan's surface like a conventional rover, the mission will use a drone. This drone, powered by helicopter-like rotors, will enable aerial mobility, providing the ability to explore multiple locations of interest on Titan. This unique capability will allow Dragonfly to analyze a variety of environments, from dunes and mountains to the vast seas of liquid hydrocarbons on the Moon's surface. Dragonfly's launch date is 2027, and the mission is expected to arrive at Titan in 2034. Once there, the drone will make multiple flights over several years, collecting data and samples from the surface and analyzing the atmosphere and geological characteristics of the Moon. Equipped with state-of-the-art scientific instruments, Dragonfly will seek to understand the complexity of organic chemistry on Titan and evaluate whether conditions on this moon could have supported any form of life, even in its distant past. As you can see, even though Titan is a very distant world compared to the Moon or Mars, there is enormous interest on the part of the scientific community to study this natural satellite in more depth, and that is why this project is being proposed to reveal all the secrets of Saturn's largest moon. So, isn't it tough to go to Titan? Difficult or necessary? Sending a mission to Titan is difficult. It's much more challenging than going to Mars or the Moon. Titan orbits Saturn, and this planet is at about 888 million miles, 6 times farther than the average distance from Earth to Mars, about 140 million miles. A mission to Titan takes 6 times longer than a mission to Mars, and the further we want to send a spacecraft, the more expensive it is in terms of budget. For that and many other reasons, it isn't easy to reach Titan, but it is necessary for the progress of humanity. Titan is a world very similar to what Earth was like millions of years ago. It has an enormous amount of natural resources that we can take advantage of, and it has geological and atmospheric characteristics that no other celestial body in the solar system besides Earth has. Studying this world in more depth is essential to understanding all the geological processes that can give rise to life. If we strive to understand better what is happening on Titan, we will also better understand what is happening on our planet. Everything we know about Titan is very recent, so the first missions with robots are planned to explore it in more detail. We still have a long way to go before we can send out manned missions, but at the rate we're going, slowly but surely, Titan may one day be home to a future human colony. And what do you think? Do you think that one day we will be able to send a human crewed mission to Titan? Let us know your opinion in the comments.